So on the next part of the review, we're going to graph parabolas. And so we're going to go ahead and extract this information here and then use it to graph it and sketch it. Okay, so the vertex, it's the highest or lowest point on the graph. And so what happens here is if I were to plug in a -1, what would happen is my graph would equal a 4, right? Because if I plug in -1, this would go to 0, my function would equal 4. That would be the highest point possible. Because if I plug in anything other than -1, I'm going to get a negative result because I have that negative right there. So the way the parabola is going to look is something like this, okay? And so I just found that point right there at -1, 4. And we can actually go ahead and plot it now. So it's right here. So that means I am going to have some x-intercepts, and we'll figure those out in a minute. Axis of symmetry is always just x equals whatever the x value was for the vertex. And so that just causes a little vertical line going through the graph. And so that'll help us when it comes time to graph it. Oops. My eraser's not working. There we go. That'll help us find some additional points sometimes by using the axis of symmetry. Okay, so now we'll go ahead and find those x-intercepts. So if you want to find your x-intercept, we're going to go ahead and let y equal 0. In this case, we're using the notation f of x. Same thing as y. So you let y equal 0. So we're going to be left with 0 equals negative, let's see, x plus 1 squared plus 4. And so we need to solve this. There's a couple of different ways you could approach this, but the easiest path would actually be to add x plus 1 squared to both sides. Oops, the wrong button. So let's see, we're going to add x plus 1 squared over here also. So that'll cancel out. So now you have x plus 1 squared equals 4. And then y'all should know how to solve this. We've done this in the prior unit. Use square root both sides. And so you have to put that plus minus right there. So you get x plus 1 is equal to positive -2. And so then we'll go ahead and subtract 1 from both sides. So you get -1 plus or minus 2. So you have to look at it both ways. You got to add 2, which would give you a positive 1. And then if you subtract 2, that would give us a -3. So those are our x-intercepts right there. And we can go ahead and plot those. So we have one here at 1, and then we have 1 at -3. So honestly, you could probably get a pretty good drawing with just those 3 points, but I am going to ask you for the y-intercept, so that'll actually give us an additional 2 points once we reflect it across the axis of symmetry. So we'll go ahead and do that. So if we want to know the y-intercept this time, we'll go ahead and let x equal 0. I'm just going to grab the original function. So f of 0, so we're going to plug in 0, so negative, oops, 0 now, 0 plus 1. Let me clean that up. My apology. That was just messy from the beginning. Okay. All right, so oops. Pins wanting to go crazy on me today. All right, so -0 plus 1 squared plus 4. And so right here, this becomes 1 squared. But that negative is kind of waiting after you square it. So you square it and you get 1, but it's really going to be -1 plus 4. So we end up getting a 3. So we get 3 right there. So my y-intercept is that when I let x equal 0, y is going to be 3. So I can make that an ordered pair, or I could have used the notation I used up above. So however I want to do that. So that gives me a point at 0 up 3, 1, 2, 3. And what I was saying before is I could actually go ahead and reflect it across to the other side of the axis of symmetry. And I'm ready to go ahead and make a little rough sketch of this. And so here we go. That's going to be good enough there. And that's good enough there. Okay. And then the last part would be the range. So the range, it's not bounded below. You know, those arrows point below. So there's nothing holding it from going down. So the y values go to negative infinity. And they peak at 4. They peak up here at 4. And that's it. Okay, so there's one. Now we'll look at another one here. Okay. All right. So similar process. So this time, oops. This time here for my vertex, if I were to plug in a positive 2, this would go to 0 and I'd be left with a negative 9. Now, this example is a little different than the last one because that will actually be the lowest point that I could possibly have on my graph. Because now if I plug in anything other than 2, it's going to get squared. So whether the parentheses is positive or negative, I'm going to end up with a positive number, which then is going to combine with this minus 9. So really, I have nowhere to go but up from there. And so the vertex is right there. It's going to be that lowest point. So it's going to open up. Axis of symmetry is x equals 2. All right. Once again, we can go ahead and plot this now if you'd like. So let's see, we're at 2, negative 9, which is down here. And then my axis of symmetry just cuts right through it. Okay, so let's find our x-intercepts. And so we'll go ahead and let f of x equal 0, essentially just letting y equal 0. So I'm going to have 0 equals x minus 2 squared minus 9. And so we'll go ahead and add 9 to both sides to kind of get started. A little different than the last problem. The other problem I had moved the parentheses over. So that cancels out. Now what I am going to do though is I am going to write the x minus 2 on the left side and put the plus 9 that was on the left side. I'm going to move it to the right side. Just the way I like how it looks. But really from here, I mean, the process is not really all that different from what we just got done doing on the previous example. So x minus 2 equals positive negative 3. And then we go ahead and add 2 to both sides. So we get x equals 2 plus minus 3. And then now you need to look at it from both perspectives. So plus 3 would give you a 5. Take away 3 would give you a negative 1. So those are our x-intercepts. We can go ahead and put those on there. So negative 1 and positive 5. I could probably make a pretty good sketch of it, but we'll go ahead and find that y-intercept to help me out a little bit more, get a little more accurate idea of what this is going to look like. So for my y-intercept, go ahead and let x equal 0. So we'll do f of 0. Okay, so let's see, that's going to be 0 minus 2 squared minus 9. And so that gives me negative 2 squared. So when I square it, it actually becomes positive 4. Take off 9, I end up with a negative 5. So when I let x equal 0, y equaled negative 5. And so that's going to be right here. And then once again, I can just go ahead and reflect it across. And so there you go. 5 points is plenty. And so we'll go ahead and try to draw this with a nice little bowl-shaped curve. It's got a little messy there, but that's okay. That's fine. That'll work. All right. And then now the range, this time we are bounded below. I only go down to negative 9, so I can't go past negative 9. But going up, there is no limitation, so it goes up to infinity. All right. Okay, so I have 2 more examples on the next slide. We're just going to be in a slightly different format. Okay, so this is standard form. These first two are standard form. Okay. Okay, over here we're not in standard form. Okay, we're in general form. There's a couple ways you could do this, and I'll do one each way. I think that'll probably be a good idea. So this one right here, I could do completing the square and make it look like the previous page, or there's a little formula you can use to find the vertex. And so really you could do it either way. Actually, no, I'm going to go ahead and show you all the formula because I believe in the notes I showed you how to do completing the square. So a little trick to find this, there's a little formula. You do negative b divided by 2a. And then to find the second part, you just plug it into the function. You plug in what you just found, and that actually gives you the vertex also. Okay. If you want to do completing the square and put it in standard form, you can. Okay. This is kind of a little cool little trick, so I kind of want to show it. So let's see. This is your A, your B, and your C. So to figure out the x value of my vertex, all I have to do is take negative 6 and divide it by 2 times my A value, which is 1. So that gives me positive 6 over 2, which is a 3. So that is my x value for my vertex. So it's a nice little trick. Now, when it's in standard form on the previous slide, you couldn't do this unless you were to transform it to general form, which really is kind of unnecessary. You would just leave it in that form and solve it the way we were on the previous slide. But this is a nice little trick though. So you figure out the x value. Well, you want to find its partner, you plug it in. So we'll go ahead and do f of 3. So we'll have 3 squared minus 6 times 3 plus 5. So we're going to get a 9, take away 18 plus 5. So 9 take away 18 is negative 9. Add 5 to that, and you're going to get a negative 4. So its partner here is going to be negative 4. Okay, so let's see, we're at 1, 2, 3, down 4. So we're right there. That's where the vertex is, and the axis of symmetry would just be x equals 3. Okay, so now to find the x-intercepts, I mean, we could do completing the square, but it's actually going to be much easier just to go ahead and factor it. It is factorable. Okay, so coming down here, if you want to find your x-intercepts, you go ahead and take this and set this equal to 0, and it should factor very nicely. So it factors into, let's see what that, minus 5 and x minus 1 equals 0. So if you were to figure out those solutions, that should be 5 and 1. So 5 and 1. There's 1. There's 5. Okay. And the y-intercept on this is actually super easy. Okay. If you want to figure out the y-intercept, in this format, it's pretty easy because if you let x equal 0, everything's going to zero out except the constant on the very end. So 0 squared minus 6 times 0 plus 5. What happens is you get 0 minus 0 and then a plus 5, so you just get that 5 right there. So if you let x equal 0, y is going to be 5. And so that's going to be right here. And then once again, you could reflect that across over to there. So we'll go ahead and draw this. Looks pretty good. It's not too bad. Trying to make it a little curved at the bottom. A little sharp, but that'll be fine. Okay, the range looks like it's going from -4 up. We're going to go from -4 to infinity. Okay, so just notice the difference between this problem and the previous two is the format of it. So in order to find the vertex, we did something a little different, okay? If you really wanted to, you could manipulate it and make it look, put it into general form. Okay, and then finding the x-intercept wasn't too bad. I just factored it, and that was good. All right. So this one down here, once again, you could kind of do it either way. You could kind of do the little trick to find the vertex, or if you want to manipulate it and put it in general form, you can. I think probably in the long run, it's easier to use our little trick. So to figure out your x value, you do negative b divided by 2a. Okay, so that would be equal to negative 4 over 2 times 2. And so then you get positive 4 over 4, which is a 1. So we figured out the x value for the vertex by using that nice little trick. Okay. Now we go ahead and substitute it in to figure out the y value. So let's see, 2 times 1 squared minus 4 times 1 minus 6. So then we get 2 times 1 minus 4 minus 6. So 2, take away 4, take away 6. That all adds up to negative 8. Okay, so we're at 1, negative 8 right down here. Okay. Same deal with the x-intercepts. If you want to find those, it shouldn't really be all that bad. Basically, you're going to let, f of x equal 0. So we'll end up with 2x squared minus 4x minus 6. You set that equal to 0 to solve. And you might notice you can make your life a little bit easier when you're solving this. Just divide both sides by 2. Okay. Try to give myself a little bit more room. So I gave myself some more room. I'll scroll back up in a second. So let's see, x squared minus 2x minus 3 equals 0. Okay. And this should factor pretty easily. So let's see, minus 3 plus 1. So those solutions I'm getting are positive 3 and negative 1. So positive 3 and negative 1. So I'm going to go ahead and start scrolling back up so we can put that there. So let's see, positive 3 and negative 1. And I'll go ahead and add that axis of symmetry. All right. So let's see it. Positive 1, 2, 3, and then negative 1. There we go. Okay. And then the y-intercept, once again, is pretty easy to find because we'll go ahead and do f of 0. And when you plug in 0, what's going to happen is you're only going to be left with that negative 6 on the back right there. Because all the 0 for all the other x's cause those terms to go to 0. So our y-intercept is going to be at 0, negative 6. Negative 5, negative 6. So right here, and we'll go ahead and reflect that over right there. Now this one is going to be a little tricky to graph just because it's a little bit tighter. The walls of this graph right here, so I'm going to try to do my best to put a curve on that bottom part, but it is a little bit more challenging. Okay, there we go. And then the range is going to be from negative 8 up. So from negative 8 up to infinity. So just notice the different approaches from general form and standard form. You could do some manipulation to make these look like the general format if you really want to. But this, from my experience, students typically do like this little formula here. It's nice and easy. So anyways, all right, that concludes parabolas.